All right, Algebra 1A students, welcome to part 4 of your video on lesson 6.3, where we're continuing to solve systems of equations by elimination. In our last video, we got introduced to the idea of multiplying an entire equation by a number so that we could make two of the numbers the same so that we could eliminate a variable. Okay. Now, in this video, we're going to take it one step further to the most difficult type of elimination we're going to see, and that is when we have to multiply both equations. Multiply both equations to make a number the same so that we can eliminate a variable. Okay. In this video, we're going to have to multiply both equations by something to make one of our variables have the same number on it in each equation. And you'll see what I mean here in just one second. Take this system of equations, for example. It says 3x plus 2y equals 1, and 4x plus 3y equals negative 2. Okay, what you should notice is none of these numbers on my variables are the same, and none of the numbers on my variables can be turned into any other of these numbers or the other number by multiplication. So we can't just multiply one of these equations by a certain number. We have to multiply both equations. Now we can choose which one we think is going to be easier to multiply. And in my opinion, neither looks easier than the other. So I'm going to decide to eliminate my x variables, which means I need to turn the 3 and the 4 into the same number. Okay. The best way to do that is start listing out multiples of 3 and multiples of 4 and find where they are the same. Okay. So multiples of 3 would be like 3, 6, 9, and 12. And multiples of 4 would be 4, 8, 12, 16. And we should see in this set of multiples that 12 is the first multiple where these two equations or these two numbers intersect. So what I need to do is multiply the top equation here by 4, because that will turn that x number into a 12. 4 times 3 is 12. Then I'm going to multiply the bottom equation by 3, because that is going to turn the bottom equation's x coefficient into a 12 as well. When I multiply both of these equations, here's what I get. The top equation becomes 12x plus 4 times 2 makes 8y equals, on the other side, 4 times 1 makes 4. So I have this equation in my top equation. My bottom equation, 3 times 4 makes 12x plus 3 times 3 makes 9y, and that's equal to 3 times a negative 2 is a negative 6. Okay. So here are my two equations, and now I see that this is something I can solve by elimination. I'm going to subtract the two equations because the x values are the same. So when I subtract the two equations, 12x take away 12x goes away. 8y take away 9y gives me negative 1y. And then on the other side, 4 take away negative 6. Taking away negative 6 is like adding, and I end up with positive 10. And now to get y by itself, I just need to divide by a negative 1. And I end up with y equals negative 10. Okay, when y equals negative 10, I just need to plug that back in to one of my two original equations and solve for x. I'm going to plug it back into the top equation because those numbers are smaller, but it really doesn't matter which one we do. So when I plug it into that top equation, what that equation then says is 3x plus 2 times negative 10 equals 1. Right? Now 2 times negative 10 is negative 20, so I have 3x minus 20, plus a negative is like minus, equals 1. 3x minus 20 equals 1. That's something we can solve pretty quickly for x. We get 3x equals 21, and therefore x equals 7. Okay, so I have x equals 7, I have y equals negative 10, and I'm ready to write my coordinate point, 7, negative 10. That's my final answer for this system of equations. Now, remember, it took multiplying both of those equations by something to make elimination possible. So in this video, like I said, we need to multiply both equations by a number to make one of our variables the same so that it can be eliminated. Okay? I have one here I would like you to try. I would like you to take a look at this system of equations and try to solve it using elimination. 4x plus 3y equals negative 19, and 3x minus 2y equals negative 10. Okay, so take these equations and multiply both of them by something to make the variable able to be eliminated. Solve for each x and y, and then come on back and I'll show you what we should have. All right, now what I need to do is multiply the top and bottom equation. The way I would do this problem, I would multiply maybe the top equation by 2, make that a 6y, make that an 8x, and make this minus 38. Whoops. 38. And I would multiply the bottom equation by 3, make that 6. Whoops, 6. Make this 3 times 3 is 9, and make this 30. Right? And now I have 6x and 6y that are both, 6y and 6y here, and I can eliminate by adding because these have opposite signs. One is plus, one is minus. So I will add together these equations. I get 17x equals negative 68. And when I divide by 17, I get x equals negative 4. So x is equal to negative 4, and I'm going to plug it back into one of my two original equations. Maybe the front one because that has all the positives. So I'll plug negative 4 back in there. What I end up getting is negative 16 plus 3y equals negative 19. And when I solve that, I pretty quickly get y equals a negative 1. Okay. So I'm ready to write my coordinate point here, negative 4 comma negative 1, x comma y, x first, y second. There's my answer, and I've solved the system of equations. Okay. If you have questions about multiplying both equations by something in order to eliminate, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.